Portugal multiple times before, but it's always nice to be back. So today I'm going to talk about some of the recent work that we have done. How do you achieve socially responsible and trustworthy AI? Just a few words, so that essentially some of the background that I have and technology in general. And partly is because the availability of the data that comes in so many different forms, whether it's 2D, 3D, images, drawing, paintings, text, audio, videos, medical records. Medical records can be any kind of imaging data or even patient information. 3D geometries and different kind of models that are captured, motions, the shape, the simulations, even the metadata, such as document and abstract information off the social medias and web. And the last but not least, some of these sensor data that we see, temperature, for example, satellites, traffic data. We don't think about them as sensor data, but they are. They are actually capturing all kind of information around the environment we have, the soil, soil moistures, and they essentially, all these data, they represent samples of all kind of informations and all different kind of sources. So given all these data, can we know and learn and predict more about the world we live in? And that really, in my view, is what machine learning and AI has been trying to do for the last decade or so, and much more. I also want to highlight that artificial intelligence, AI, wasn't born a decade ago even. It was dated back, way back in the 70s and 80s. And when I was a grad student, AI was still a novelty. But already when I was a grad student, AI was hitting what's called an AI winter. And part of it was because there wasn't enough compute, and there wasn't enough resources and not enough data. Many of the principles that we are seeing today, including neural network, was actually invented in the 80s. And it was tiny. So having seen the evolutions of artificial intelligence or AI in general, and I actually focus a lot more on the subfield of robotics. One might think robotics is in AI, or the other way around. Robotics is embodied AI, physical AI, however way you want to say it. It really is sort of interesting to see how things has evolved. But I believe that the data-driven revolution that we are seeing is not only enabling AI to be such a powerful tool and be predictive of what's going on into the future. It also makes reconstruction of the past events possible. It allows us to synthesize information and to predict what may happen. In most interesting way is the dynamic world that we live in. Things that are changing constantly. And nothing else is the weather. So my vision on the future training computing is to, using AI, to capture and reconstruct the dynamic real world, the physical world that we have, to bring this physical universe into metaverse. I know Meta just recently laid off a few people. And a part of Meta laying off the few people is mostly groups that work on virtual reality. However, I think they might reconsider that decision a few years down the road. But I think a metaverse is much broader. It's not necessarily through the lenses of VR. But metaverse is emerging and the integration of the digital and the real world. VR as an immersive environment is just a way of enhancing that experience in a much more immersive way. But it's really not the end. It's really just one of the means. And I believe that the future of computing is going to enable us to have a much more seamless transition back and forth in the metaverse that will bridge the gap, or perhaps smooth and transcend that boundary between the digital and the physical world. And it will enable us to create what's used to be considered as impossible. It will able to enable us to predict the system evolution, the future events and demands, and it could create a virtual digital ground for us to experiment things, for students, for scientists, for engineers, and for educators. And I believe the Meta Lab is going to enable us to test hypotheses, design new artifacts, and validate and prototype all kind of experiments. So that is what I think can be enabled with everything that we have. AI is going to be part of this metaverse. However, there are some challenges, and the challenges will come in mainly, or I'm going to categorize them into two different forms. One of them is the data challenge. The diverse representations of data and format that we are seeing is only the beginning. We have 2D versus 3D versus very high dimensional data. We have text, numbers, images, audio, videos, abstract information. We have geometry, physics, appearance, and behaviors. All these are diverse forms of data, and I want to say we are part of that data. At the end of the day, the world is not so interesting to us if we are not part of that data. So all kinds of human data is part of that data. And the other thing is the volume of data and the associated compute with all these data that we have to process. Just imagine every single piece of data that we have to touch it at least once with some form of computing. We have to process it at least once, and that's linear. And how many different kind and different pieces of data that we have? Huge. It's way beyond trillion, and it's way beyond petabytes. So along with the compute, we're going to have to deal with cooling, electricity consumption, storage, and memory. We're already seeing the impact as such. And in addition to that, data are captured through all different sensors and in different form. So there are biases, there are noises, there are uncertainties, there are incompleteness in the data capturing process. And what's even worse yet is there is inadequate taxonomy, ontology, and categorization of all these different data. And most of all, most of us who are capturing data, we're not thinking about context. We're not thinking about, oh, we are doing this for research. We're just capturing it. So they are captured in a very non-contextual way and not in a controlled setting. So together, we're dealing with lots of data that are not standardized in any way, the way that we are capturing. And in fact, that we have possibly too much of some data and not enough of the other data. And I would posit and say, I believe that if we're going forward to the future and continuing this data revolution that we're going to be going through, we really need to take a step back and think about how do we capture data and how do we evaluate the data that we have and not process every single piece of data like it's some valuable information. And the other thing I would also argue, as an academic, I publish a lot of papers just like most of you, and it really, get me to think, what are we doing when we think data is the ground truth? This is one of the things I constantly give on the reviewer. Data is the ground truth. Is it? After I just said, is data really the ground truth? I like to take this opportunity and say, no, data is not the ground truth. Data is just one biased perspective of observation, captured from any particular perspective, possibly with sensor noises, possibly with biases of perspective, with lots of incompleteness. How can ground truth be having so many holes and so many problems? So data is an artifact just like everything else. So we have a challenge of how do we deal with the data that we are given? That does not necessarily represent a ground truth, but just an artifact of our observation. And then from that observation, how then do we get to the point where we actually predict these information that we are trying to get through AI or any other statistical, mathematical, physical means? So on the technical challenging side, this is what we have to deal with. We have lots of generative AI and data-driven methods that offer empirical models, not analytical models. We have a lot of black box results that are not always interpretable. How many of you think that you can read the output of a neural network and you can tell what's going on? Not me. Again, not my students. And we did try, and do you think the results from all these neural networks is interpretable and explainable? Yes.
I think exactly the same goes for humans. So it's really, I'm really totally unable to say based on your neural network patterns in your head what's going on. So we're in exactly the same position towards a neural network as we are towards a human.
Okay, that's a really interesting observation. Yes, but I'm going to argue. Does a computer need to mimic a human? That's a philosophical discussion. All right, and I know I am one of the AI machine learning people, and somebody the other day just asked me, what do you think of human-driven, basically learning directly from human for a humanoid robot? And I look at it and I say, okay, do you think the robot hand is the same as a human hand? So do you think the robot should grasp the object just like human does? Check your hand, check the robot hands. Metallic hands versus soft fingers. Are we the same? So those are kind of things that I think is worthwhile for us to kind of think about as we evolve in this era of AI. What does this mean? And I'm not here to offer solution. I'm just here to sort of share some of the experiences I have and then some of the work we have seen. But I think the problem that we have, the technical challenges we have, is that we don't really know what some of these neural network does. And we're just coming out with lots of architecture. As somebody who also have not just computer science background, but double E background in signal processing, my joke is AI is, or exact, not AI, but neural network, is like any system. Garbage in, garbage out. So if you don't have good enough data, how do you know your prediction is any good, right? So what we have is a lot of time is limited and incomplete sets of observation. And that is something we have to address as a community. And another thing that we have seen is the generalization to unseen domains and scenarios is often lacking. And it's exactly what I just mentioned earlier, is we've seen a lot of humanoid robot out there and performing grasping and tasks using human data and just simply replay. The reality is if you download our software and try to run it in your labs, it doesn't really grasp anything else other than the one that I demonstrate on. So a lot of these results are not transferable across different tasks. And even if it can grasp a cup, it may not be able to pick up a ball or a bottle. And it's also not robust with input and domain variation, and learning is purely from data can be extremely costly. My simple question is for you. How many different tasks do you have done, or have you have done in a single day? And what are all different possible interactions? Trying to capture data for all those scenarios. How many data centers do we have to build? So those are the kind of questions I think we're gonna have to think about, and I think about that a lot as a researcher, because I believe AI can really make a difference, not just as a processor for, that comes in an awfully large language model. I often joke, language is 1D, images are 2D, the 3D world we live in are 3D. The